This is Team 23, Functional Catastrophe. This is our final report, talking about things that we did throughout our project that maybe were challenges, some stuff that we would maybe change, and things we might do next. Personally, I think the very beginning of the project was pretty challenging, just nailing down the full scope since we wanted to do an EMG-controlled hand. But beyond that, the 3D printing was a lot more difficult than I originally thought. It took a long time. We had several failed attempts, and each failed attempt took several hours, and then we had to resubmit. Not several hours, several days, and then we had to resubmit. So that was my biggest challenge personally. Things that I might go back and change, I think maybe look at a different set of hands, like a linkage hand instead of a tendon hand, because we have passive opening of the hand, only active closing. It'd be cool to maybe look into that. Future work, I'd like to do multivariable control on the hand so that we have a little more user control of the movements. Next up, Moe is going to talk about his section of the project and what he would like to do.
Yeah, so I found the biggest challenge for me was the print circuit board. It wasn't until demo day where I could highlight some parts of the print circuit board, like the EMG section, that were fully operational. What I would change differently with the EMG subsystem, I would probably increase the power of the circuit so I can improve performance like common mode rejection and noise performance. So the EMG would be more sensitive to the user's inputs and would be easier to implement on the Arduino Do. Future work for me, it would have been cool to add hardware calibration because everyone has a different EMG signal. It would have been cool to look at a system on a chip solution that incorporates most of the electronics. Where it would be nice to include the ADC that I put on the board and SPI isolation to make the EMG system fully isolated, and maybe different isolation techniques like a transformer, or maybe just isolate the USB. And, yeah, that's about it for me. Cameron, you want to talk about your?
Yes. So one of the challenges I faced was needing to have a physical hand in order to properly get realistic characterization for the pressure sensors. What I would probably change is if I had enough money to purchase all the parts to make a separate secondary hand so that I can do my characterization and Perry-Jacques can continue his computer controls. Otherwise, I could have handed off my LED representation of the hand for Perry-Jacques to use, and then I could use the hand for pressure sense characterization. In the future, I'd like to do a pseudo-random binary sequencing to characterize the pressure sensors on the fingers, and that would take into account any physics from the actual hand, like the yields of the digits and also the give and the tendons. I would also like to implement a pseudo-random binary sequencing for like a user program, so a user can do like a quick flex, 2 long flexes, and another quick flex, and we can get the extrapolated data and take a 10% average of that, and that could be our threshold that Perry-Jacques can use for his computer control systems. And next, PJ can talk about what he would like to change.
Hi, yeah. So apart from what Cameron already added, I will be responsible for implementing any and every change that is taken from the variable EMG to changes in the PCB, the way we capture signal, as well as implementation of the pressure sensors onto the arm itself. I would love to give user a light or an audio feedback. One of the major challenges that I faced was implementing all of these subsystems simultaneously on the same microcontroller. Running everything together was a big challenge, and it took a really long time to figure everything out. I had to kind of trade in sampling rate to get the digital switch to move the arm every time we flex work. Other than that, yeah, I would love to make a automated function that could calculate the threshold like Cameron suggested. So you can just put on the patches, flex a couple of times, and the arm will figure out what kind of a threshold it needs to set so that the arm is functional for any and every user. Yeah, and that's pretty much it. Hope you guys like it.